Hello students, welcome back to your favorite and India's most affordable learning platform, Physics Wala. So in the last session, we covered the mechanical properties of fluids, lecture number 2. So where we discussed about the pressure, how the pressure varies in an accelerating fluid, right? So vertically accelerating fluid and horizontally accelerating fluid, and what will be the shape of the liquid, so in the accelerated fluids. And we also discussed the manometer and barometer concept. Chalo. So today in the lecture number 3, where we are going to focus on the upthrust or buoyancy. So you already learned that in grade 9th. So here we are going to discuss in detail. Okay. And the Archimedes principle and what is the law of flotation. Okay. Chalo. As usual, I just need your attention for the next 1 hour. Just be with me, avoid all the disturbances around you guys, and at the end of the lecture, it's a very important to prepare your own short notes. Chalo. So let's get into the today's topic. So first, what is upthrust or buoyancy? See, so when an object is placed in a liquid, if it is placed in a liquid, so let's suppose it is floating this way. Any object, let's suppose it is floating this way. Okay, so here if you observe, some of the solid, some part of the solid is immersed in the liquid and some part is floating. Yes. Now, so what are all the forces that are acting on the body? So what are all the forces that are acting on the body? So there will be a force which acts upward when an object is immersed inside the liquid. So that force we call it as the buoyancy or the upthrust. So the upthrust or buoyancy which acts upward when an object is immersed inside the liquid. So what's the upthrust formula? So simply remember the formula. U is equals to rho F Vf, let's write Vf rho F into G. So Vf rho F into G. So this is a upthrust or buoyancy which is denoted by U. So write down. So U is a upthrust or buoyancy. Clear? Done. So now let's move further. So what is Vf and what is rho F? What is G, sir? G is the acceleration due to gravity. You already know that. And then what is rho F? Vf first. So what is the Vf? So it's a volume of liquid or fluid displaced. So volume of liquid displaced or so we can also write it as the volume of the immersed solid. We can also write it as the volume of the immersed solid. Volume of immersed solid. So very important, whenever an object is immersed in a liquid, so then what happens? So some water, some liquid will be displaced. So that Vf is nothing but volume of the liquid displaced, or it's a volume of the immersed solid. Okay, and then rho F is a density of the liquid or fluid. So it's a density of the given fluid, whatever it is. So here this can be water or oil or any other fluid. Okay, so G is the acceleration due to gravity here. The small g is the acceleration due to gravity. Done? Yes, good. So just you will understand all these concepts step by step. Just follow the concept. Okay, chalo. Now, so what Archimedes principle says? So Archimedes principle actually defines the buoyancy. That's it. So the buoyancy is nothing but U is equals to, so Vf rho F into G. So remember this one. So now what Archimedes principle states? When a body is immersed wholly or partially in a fluid, it is lifted up by a force equal to the weight of fluid displaced by the body. See here. So first understand the statement. when a body is immersed wholly or partially in a fluid, when a body is immersed wholly or partially in a fluid, so then it is lifted up by a force which is equal to the weight of the fluid displaced by the body. So it is lifted up by a force. What is the force with which it is lifted up? The buoyancy. Yes or no? So that buoyancy, they are saying, is equals to, it is lifted up by a force which is equals to weight of the fluid displaced. It is the weight of the fluid displaced. The weight of the fluid displaced. Clear this part? Chalo. So this statement you should remember. The upthrust is nothing but, so see here. So it's a weight of the fluid displaced. Remember this one, weight of the fluid displaced. Chalo. So now let me write it in the next slide. Just follow the concept. I'll go slow only. So just follow the concept. So the upthrust is equals to, so weight of fluid displaced. So now, so what is the weight of the fluid displaced? So let the m be the mass of the fluid into, so g is the acceleration due to gravity. So m is the mass of the fluid into g is the acceleration due to gravity. That is called the weight. Yes. Now what is mass of the fluid? So we know that the, let's write, so the mass of the fluid mf I am writing. Okay. So we know that the density of the fluid is equals to mass of the fluid by the volume of the fluid. Density is equals to mass upon volume. Here the density of the fluid is equals to mass of the fluid by the volume of the fluid. Yes. From here, shall I write, so the mass of the fluid is equals to rho f into Vf. Yes. So that's what I am going to replace here. In place of mf, I am writing Vf rho f into g. So this is nothing but the upthrust. So the U is equals to Vf rho f g. What is this Vf? Mainly you should concentrate here. So what is this Vf? This Vf is a volume of fluid displaced. It's a volume of fluid displaced. R. So which we can also write it as a volume of the immersed solid. Volume of the immersed solid. Volume of immersed solid. Done, guys? Everyone clear with this? Sure. So let's move further. So now you got the idea. So what is a upthrust? So from Archimedes principle also it defines actually the upthrust. So chal. So let's move further. So we got one question. So let's try to solve this question on your own, guys. Try to solve this question on your own. Chalo. So what's the question says first? A stone of density 3000 kg per meter cube is submerged in water. So they gave the fluid as water here. And then if the mass of the stone is given, so 30 kg, find the upthrust. See here. So first of all, let's consider a container. So consider this is a container in which a stone is submerged. This is a stone. Let's say this is a stone is submerged. Okay. So then the stone density is given and the stone mass is given. The density of the stone is 3000 kg per meter cube. And then, so mass of the stone is equals to 30 kg. Mass of the stone is equals to 30 kg. This is given. So now they are asking upthrust. So whenever an object is placed wholly or partially it is immersed in the liquid, so then what happens? There will be some force which is called upthrust will act, right? So that upthrust is equals to, I can write the formula. So Vf rho f into g. Vf rho f into g. So this is the density of the fluid, this is the volume of the fluid, and this is a g. See here. Now shall I say that Vf is equals to volume of the fluid displaced is equals to volume of the stone in this particular case? Because it is completely immersed. So the volume of the stone is equals to volume of the fluid displaced. Yes or no? Because it is completely immersed in the water. So whatever the volume displaced, whatever the volume of the fluid displaced will be equals to volume of the stone. So in place of what is volume of stone now? Shall I find what is the volume of stone? So I know that density of stone is equals to mass of the stone by volume of the stone. From here I need volume of the stone, which is mass of the stone by the density of the stone. Yes, see, the terms might be confusing, but make them clear. So I am going to follow this terminology only throughout this chapter. Okay, so Vs, the volume of the stone, is equals to, so mass of the stone is given 30 kg by density of the stone is given 3000. So what I am doing is, so here 3 ones are 300 times, so which is nothing but 10 to the power minus 2 I got. Clear till here? Chalo. So now here in place of Vf I am writing, so Vs into, so the density of the fluid into the density of the fluid into, so G. So what is the volume of the stone that we got? So which is nothing but 10 to the power minus 2. So volume of the fluid, which fluid it is? Water. So here all the values are given in terms of kg per meter cube only. So that's why take the density of the water as 10 to the power 3. Yes, into, so G value is 10. So which we get it as, so 10 to the power minus 2, 10 to the power 4, which is 10 to the power 2. So which is nothing but 100 newtons. So the second option. So the basic information, when a stone is immersed inside the fluid, so it experiences the upthrust. So what is that upthrust? We calculated. So here the hint that you should catch here, if it is completely immersed, if an object is completely immersed inside the liquid, so we can say that the volume of the fluid displaced will be equals to the volume of the solid, volume of the object, or we can say. So here object is stone, so that's why I took the stone. So I'll write that statement here. So let me write here. If object is completely immersed in the fluid, if the object is completely immersed in the fluid, so then volume of object is equals to volume of the fluid displaced. Volume of object will be equals to volume of fluid displaced. Volume of the fluid displaced. Clear? So this statement also you guys should remember. Done? Very good. So then I have got one more question here. So let's try this question on your own. An iron cube of mass 5 kg and side 10 centimeters is suspended by a thread in water. So find the tension in the thread. So we have to find the tension in the thread. So first, so this is a container in which some fluid is there. Water, did they mention water? Yes. So the given fluid is a water. Fine. So now a iron cube of mass 5 kg and side 10 centimeters is suspended by a thread. So here is a thread and here a stone is suspended like this. Okay, so a stone is suspended whose side is 10 centimeter. Fine. Then, so the mass of the stone is 5 kg. So the mass of the stone only na object they said. So let's say the mass of the mass is equals to 5 kg and the side A is equals to 10 centimeters. So convert it to meters. So 10 into 10 to the power minus 2 meters. So they are asking what is the tension. See what are all the forces that are going to act on this body. So if it is hanging from a support here, so this side the tension will be there. and the upside upthrust will be there when the object is placed inside the fluid. So some force, buoyancy will be there, upthrust, and then what else is there? Mg, its own weight mg. So now you can simply substitute the values. So the force plus upthrust is equals to mg, right? Chalo. So this mg is of the solid. Done? Yes. So then we need the force. So this force is nothing but the tension. I can write better. Let's write the tension force. So the tension is equals to, so what's that? Mg minus the upthrust. The tension force will be equals to mg minus upthrust. So now you can substitute the values. So here I can write mg minus, so what I can write here? So in place of upthrust, so volume of the volume of the fluid into density of the fluid into g. So let me do one more thing also here. So the tension T is equals to, so this is the mass of the solid, right? So but here the mass is 5 kg and the side is also given. So let me do one thing. So let's write so the mass of the solid, so the density of the solid into volume of the solid into g I am writing. This is a mass of the solid. Mass is equals to density into volume. We can write, right? Density is equals to mass by volume. So mass is equals to density into volume. So I'll write like this. So into, so minus, so rho Vf, rho f into g. Yes. So now what's the information that we don't know? So we know the mass of the, see here you can keep mass only, no problem. Yeah. So here m we know. So and g value we know. So but what is this one? What is this Vf, rho f we know. So rho f is nothing but 10 to the power 3. G value also you know. But you don't know what is the volume of the fluid displaced. So the volume of fluid displaced is equals to, I'll write it in the next slide. Chalo, better. So here the volume of fluid displaced is equals to volume of the object or volume of the cube. I can write directly. So the object is of the shape cube, right? Because it is completely immersed in the water. So the volume of the fluid displaced equal to volume of the solid or the cube. So what is the volume of the cube? I can write. So it's a cube. Yes or no? Volume of the cube. So what is A? So 10 into 10 to the power minus 2. So 10 into 10 to the power minus 2 whole cube. So which I can write it as, so this is 10 cube into 10 to the power minus 6. So which comes out to be 10 to the power minus 3 meter cube. So this is the volume of the fluid displaced. So now substitute the values. So this mass is 5 kg into, so g is 10. So this whole thing is 50 minus, so volume of the fluid displaced. So what's that? 10 to the power minus 3 into, so what is the density of the fluid? So here the density of the water is nothing but the density of the fluid. So which is 10 to the power 3 in kg per meter cube I am going to take. Done? Good. So now this is 10 to the power 3 into g. So g value also you substitute 10. So 10 to the power minus 3 plus 3 gets cancelled. So this is 50 minus 10. So which is 40 newtons. So the correct option is 40 newtons. Option 3 is the correct one, guys. Done? Everyone? Clear? Chalo. Simple question again. So now let's try this question on your own. Let's try this question on your own, guys. So what's the question says? First, a stone of relative density K, so is released from rest on the surface of a lake. So if no viscous effects are ignored, so that means there is no frictional force. So the stone sinks in water with an acceleration of, what is the acceleration of the stone with which the stone will sink in the water? See here, consider this is a lake. Yes. So now observe, a stone is like this. So first of all, this stone experiences a force upthrust. So what is the force? The upthrust upside, and the stone sinks with an acceleration. So it goes down with an acceleration a. So and then what is its weight? So mg. Yes or no? So then if you apply the Newton's second law of motion on this, it is accelerating downward, so that more force will be, mg will be upward, so the upthrust is less. So I can apply the Newton's second law here. So the mg minus upthrust is equals to, so the mass into the acceleration. Mg minus upthrust is equals to m into a. So this part clear, everyone? Just the stone is accelerating. We drop a stone into the lake, so it's accelerating downward inside the liquid. So with what acceleration it is sinking? That's what they are asking in the question. So for that, so as it is accelerating downwards, I applied the Newton's second law here. So its weight is mg. So and other force that is acting on it is upthrust, so which is in opposite direction, but it is going downwards, means mg force is more, upthrust is less. So more force minus less force is equals to, I can write mass into acceleration. Yes, Newton's second law. So now let's do one thing. From here you should do the work. So in place of this mass, what is this mass? Mass of the stone, right? So let me write, in place of mass, I'll write the density of the stone into volume of the stone into g. Let's write minus, so the upthrust. So what's upthrust? You can write, so rho f vf g. So let's write the reverse way. So vf rho f g, so is equals to, so this is a mass of the stone. Again I am writing here, so mass of the stone into volume of the stone into the, mass of the stone, volume of the stone into the acceleration a. Now, so they are saying the relative density is k, so let its volume be v. I am considering, let its volume be v. We don't know what is the volume, so let the volume of this one is v, so and the density is k. So let's write relative density. They said let's take it in 10 to the power 3, so kg per meter cube I am going to take, into g minus, so volume of the fluid. So what is the volume of the fluid? So shall I say here volume of the fluid will be equals to the volume of the solid. The volume of the fluid displaced is equals to volume of the stone, because it is completely sank, right? So let it be equals to v. We considered already. So then in place of vf also I am writing v. So what is the rho f, density of the water? So density of the water did they give? So let the density of the water be 10 to the power 3 into g is equals to, so what's the density of the stone? So we can write k, the relative density I am taking, so into volume of the stone. So what is the volume of the stone? V into 10 to the power 3 into the acceleration a. Yes. So now, so let's write this one. So anything we can cancel, so the v we can cancel, and anything else, so 10 to the power 3, 10 to the power 3, 10 to the power 3 cancel. So I can write here, so kg minus g is equals to k into a. So they are asking with what acceleration it is going down. So the acceleration a I required. So the a is equals to kg minus g by k. So which I can write it as kg by k minus g by k. So just I am splitting this denominator to both the terms. So k cancel. So which is equals to g minus g by k. G minus g by k. So which is, or else I can write, so g I can take common. So which is 1 minus 1 by k. So g into 1 minus 1 by k. Option 3 is the correct one. Clear guys? Everyone done? Just follow the basic procedure. See, all these questions we are just doing based on this formula only. We are not going beyond this formula. Yes or no? So this one. So but you should have the basic knowledge of the concepts. Chalo. So let's go for the next concept. So what is that apparent weight of a body? See, so in general life also you might have observed this. So when you lift an object, let's suppose if there is an object which is 5 kg on the ground. So when you lift it, so it's 5 kg. But the same object, if you place it in the water completely, so then if you lift it, so you may not feel the, you may not feel its weight is same 5 kg, its mass is same 5 kg. Why? What's the reason? So because, so there is some other force which is acting. So what is that? The upthrust, right? So there is on this object which is placed inside the liquid, so another force that is acting is the upthrust. Getting? Yes. So now let's suppose you are trying to lift it with a force of F. So then let its weight be mg. So just draw the free body diagram. Newton's law, just draw the free body diagram. So yes or no, this is the force with which you are trying to lift it up inside the water, and already there is a force which is upthrust. That means this is a force with which you are trying to lift it up. So there is some other force which is supporting the force, this force. So what is that force that is supporting? Upthrust. So that's why you are able to lift it easily inside the water or inside the liquid. Done? Chalo. So when a body is wholly immersed in a fluid, its effective weight decreases. Yes, its effective weight decreases. So by how much it decreases, sir, its effective weight? So let me write. So the F plus U is equals to mg. Shall I write here? F plus U is equals to mg. So from here, so the F is equals to, so this is a, okay, mg minus U. So which is nothing but it's a weight in air minus, so the upthrust. This is what? So this is its actual weight. Mg is the actual weight minus sorry. So minus the upthrust. So this is a weight, the apparent weight. This force is nothing but the apparent weight. Weight apparent is equals to weight in air minus, so the upthrust. So this is a upthrust. Clear, guys? Understood this part, everyone? So chalo, so note this down. I'll just have some water. Chalo. So the apparent weight is equals to, so weight in air minus the upthrust, So here, so let's write, so the weight apparent is equals to, so I'll write weight in air, its actual weight in air is m into g minus, so let me write what is the upthrust formula. So Vf rho f into g, Vf rho f into g. So now, so the weight apparent, so I'll not write complete one, so let's write apparent weight this way. So this is the mass of the object which is, yes or no, this is the mass of the object which is placed inside the liquid or which you are trying to lift it up. So now I'll write this one as, so the density of the solid into, so the volume of the solid into, so the g minus, so here the volume of the fluid into, so density of the fluid into g. In place of this mass, I wrote density into volume. In place of this mass of the solid, I wrote density of the solid into volume of the solid. Yes, fine. So then I'll write weight apparent is equals to, let's do one thing. So let me take, so as the object is completely immersed, So shall I write like, so the Vf is equals to Vs, the Vf is equals to Vs. The volume of the fluid displaced will be equals to the volume of the solid which is placed inside the liquid. So chalo, so in place of this density of the solid, let it be, so in place of this one I am writing, so volume of the fluid into rho minus volume of the fluid into density of the fluid into G. Yes, so now I'll take, so the Vf minus into G common. So here, or else let's write this way instead of here. So the density of the solid, let it be volume of the solid, and the G minus, in place of this one I am writing volume of the solid into rho F into G. So now see here, so I'll write, so Vs rho S Vs, so G I am going to take, so the complete thing I am going to take it out, so which is 1 minus, so here this whole thing came out 1, and then here Vf rho F is left, right? So rho F by, so the rho S, yes or no? So rho F by rho S. So this is a apparent weight. This is the apparent weight. So now the apparent weight you can write it as, so rho S Vs into G into 1 minus, so rho F by rho S. Here rho F is there by rho S. Or you can also write it as, so what is this density of the solid into volume of the solid, which is nothing but mass of the solid into G 1 minus rho F by rho S. Done. So this is the apparent weight. So the apparent weight is equals to, so we can write this as weight in air. You can also write this way. So you can also write this as weight in air into, so 1 minus rho F by rho S. 1 minus rho F by rho S. Clear guys? Everyone done with this? Chal. Done? So now, so let me write it in the another page. So the main concept that you have to remember here, it is, so the apparent weight apparent is equals to, so the weight in air minus the upthrust. This is the first thing you should remember. And then next, the second one, so the apparent weight is equals to, I can write, so the weight in air into, so 1 minus rho F by rho S. 1 minus rho F by rho S. So this is the second one. And the third one, okay, so the apparent weight or the density of the solid is equals to, so it's a weight in air by, so weight in air minus, so weight in liquid into the density of the liquid or fluid. So this formula also you should remember. Done guys? Everyone? Rho S is equals to weight in air by, rho S is equals to weight in air by weight in air minus weight in liquid, so into the density of the fluid. So write this way, by, so weight in air minus, so weight in liquid into, so the density of the liquid or fluid, whatever. So just have a look at those formulas. Just look at those formulas. So now let's go for the questions. We'll solve some questions so that you'll get the complete idea of the concept. So try to solve this question on your own guys, everyone. Try to solve this question on your own. Stone of density 3000 kg meter cube, not kg meter cube, it's a kg per meter cube, is lying submerged in water of density 1000 kg per meter cube. So the mass of the stone is 150 kg. Calculate the force required to lift the stone. See here, a stone of density is something is lying submerged in the water. So the water density is also given. If the mass of the stone is given, calculate the force required to lift the stone. See here. So if it is there inside the liquid, so it is there inside the liquid. So this is a upthrust which acts on it, and then its own weight acts mg, and then so let's suppose you are trying to lift it up with a force F. Okay, so the general equation it will be here we get, so what is that? So the force plus upthrust is equals to mg, so which we can write, so the force with which you are trying to lift it, that's what we have to find, so which is nothing but mg minus u. So now we already know, right? So what is the weight is nothing but the force, the apparent weight is nothing but the force, which is equals to, so the weight in air into, so 1 minus, so rho f by rho s, 1 minus rho f by rho s. That's what we have got, right? The formula. So simply substitute the values now. So weight is nothing but mass into g into, so 1 minus, so rho f by rho s. So substitute the values. So what is m? Mass of the given stone, which is 150 into, so g value 10 into 1 minus, so what is the density of the fluid? So what is the density of the fluid? 1000 s 1000 by, so the density of the stone 3000. So 3 zeros gets cancelled, it's 1 by 3. So which we get 150 into 10 is 1500. So 1 minus 1 by 3, which is 2 by 3. So here it comes out to be 3 5s are 2, so which is comes out to be 1000 newtons. So the correct answer is option 2. 1000 newtons is the correct answer. Clear guys? Understood the concept? Chalo. So let's go for the next question. So try this question on your own. A piece of steel has a weight W in air, W1 when completely immersed in water, and W2 when completely immersed in an unknown liquid. So the relative density of liquid is, so the relative density of liquid. So the relative density or specific gravity, we already discussed it in the first lecture only. What is relative density or what is specific gravity? Fine. So first, a piece of steel has a weight W in air. So there are two mediums, first air and the other one is a completely immersed in water. Sorry, wait. Air it is W. So okay. In air its weight is W. Now W1 in water. So when it is immersed in the water, its weight is W1. So when it is immersed in the unknown liquid, so in the case in unknown liquid, its weight is W2. Fine. Chalo. So I'll do one thing. See, I know the density of the solid formula. So the density is equals to, so the weight in air by weight in air minus, so the weight in liquid into the density of the liquid. Right? Chalo. So here let me write, so the density of the solid or the steel piece is equals to, so its weight in air is W by weight in air is W minus weight in this liquid. So first when it is immersed in the water, its weight is W1 into, so let the density of the water, so here the density of water, let's write this one. So now done. So next same formula I'll apply here. So what I'll do is, the density of the same steel when it is placed in the unknown liquid is equals to, so its weight in air is W by its weight in air is W minus, so weight in liquid, what is its weight in unknown liquid? So W2 when completely immersed in unknown liquid, so W2 into, so let the density of that liquid be L, rho L. So here rho S and here rho S, so let it be equation number 1, let it be equation number 2. So now as the LHS of equation 1 and 2 are equal, so I can compare their RHS, so that W by W minus W1 into density of water is equals to, so W by W minus W2 into the density of the liquid. Yes, so here W gets cancelled. So what we required, the density or the relative density of the liquid. So what is the relative density of the liquid? So I can write, so the density of the liquid with respect to water, I am sending this rho liquid by rho water, that's nothing but the relative density. What is relative density? The density of a substance by the density of water at 4 degrees centigrade. Density of the substance, which is density of the particular liquid by density of water. So I sent it to this side, and then you sent this one to this side. So W minus W2 by W minus W1. So W minus W2 by W minus W1. W minus W2, so by W minus W1. Option 2 is the correct one, guys. Clear, everyone? Done with this? Chalo, good. So now, what is the condition for sinking? See, so first let's suppose this is a container in which an object or a stone is placed like this. Let's consider a stone is placed like this. So now what I am doing is, so let's consider the density of the fluid is less. So let's say the density of the fluid is less. So and then the upthrust also will be less. Yes or no? So then I can say, as the upthrust is less, so the body will not sink completely. The body will not sink completely here, as the upthrust is less. So the body will sink but not completely. So in the second case, let's suppose, so it's okay. So here its weight is greater than the upthrust. So here it sinks, but may sink completely or may not sink. Okay. So here I immersed it somewhat below here compared to this one. So somewhat more depth it is into the water or liquid. So then, so here also let's suppose, so the weight is greater than the upthrust. Okay. So then here also it may sink completely. So now what I am doing is, if it is completely placed inside the liquid now, so let me take, so the weight is greater than the upthrust. So here weight, what is the weight? So its mass into mass of the object into g greater than, so the upthrust, what is the upthrust formula? Vf rho f into g. Yes. So now in place of mass, so I'll write, so the density of the solid into volume of the solid into g is greater than Vf rho f g. Vf rho f g. So here, so I can write g cancel. So if it is completely immersed, in this particular case it is completely immersed, so then the volume of the fluid displaced is equals to the volume of the solid. In place of the volume of the solid, I am writing volume of the fluid greater than volume of the fluid into the density of the fluid. So Vf also gets cancelled. What's the condition we get? So the density of the solid is greater than the density of the fluid. So then it sinks completely. Clear? So what's the condition for sinking? The condition for sinking is nothing but, so the density of the solid or the object is greater than the density of the fluid. So then the object will sink. That's a perfect sinking. Understood, guys? Clear? Chalo. So if reverse, if the density of the solid or the object is less than that of the density of the fluid, so then what happens? It will float. That's it. So now if they ask what is the condition for floating, so what is the condition for floating? What's the condition for floating? So the density of the solid should be less than that of the density of the fluid. So then it will float. Understood? Clear? Chal. So now what is law of flotation? So here, when an object, let's suppose, placed like this, when an object is placed on a liquid, so some part of it is submerged in water and some part is still floating on the liquid or water or some other liquid it can be. So now what are the forces that are going to act on the body? Tell me. So the upthrust and then so its weight. So apart from this, any other? So here the law of flotation says the body will sink, the body will float. Body will float if so the body will float if so the density of the object or the solid is less than that of the density of the fluid. This is a condition for floating. Done, guys? So just note this down. First. So now see. So if the body is floating means what does that mean? If the body is floating means the net force acting on the body is 0. If the body is floating means the net force acting on the body is 0, right? So which means it is in equilibrium condition. It is in equilibrium condition. So if it is in equilibrium condition, so shall I equate? So the upthrust is equals to its weight. Shall I equate its upthrust is equals to its weight? What is upthrust formula and what is its weight formula? So I'll write here. So its upthrust is equals to weight. Just understand the thing slowly. So upthrust is nothing but so the volume of the fluid displaced into the density of the fluid into G is equals to mass of the object or the solid into G. So now let me do, so Vf rho f into G is equals to what is the mass of the solid? So let's say the density of the solid is rho, which is equals to mass upon volume. Okay, so the density of the solid is equals to mass of the solid upon volume of the solid. So now from here the mass of the solid is equals to the density of the solid into the volume of the solid. So I'll write the in place of this mass of the solid, I'll write rho s into Vs into G only. So I'll cancel G and G. So the condition for flotation now Vf rho f is equals to Vs rho s. Vf rho f is equals to Vs rho s. Understood, guys? This statement, everyone? Clear? So what law of flotation says? When an object is floating on any liquid, so then the net force acting on it is going to be 0. So that means it's in equilibrium. So after writing the condition, we have got this. So Vf rho f is equals to Vs rho s. Done, everyone? Clear? Chal. So let's move further. So now for a cylindrical or cubical body, so let's consider I am placing a cylindrical object inside the liquid. So let's suppose it is floating this way. So this is a total height of the solid, and then so this is the height of the fluid displaced. Height of the fluid displaced. So now as per the law of flotation, from the law of flotation, so we know that the rho f Vf is equals to so rho s Vs. Now so let's consider this cylinder has the cross sectional area A. Okay, so now in place of this density, let it be, in place of this volume I am writing so the cross sectional area into, so what is the volume of the displaced, what is the height of the fluid displaced? So which is nothing but Hf. So what is the height of the fluid displaced? Hf. So which is equals to rho s, let it be, into, so volume of the complete solid. This is Vs is the volume of the complete solid. So this is Vs is, I can write, so the total cross sectional area into, so the total height of the solid. So I can cancel A on either side. So the rho f Hf is equals to rho s Hs. So this is the one more condition in terms of height. So this Hs is the complete height of the solid. Complete height of solid. whereas this one is a height of fluid displaced. Height of fluid displaced, or we can also say it as height of the solid immersed. Height of the solid immersed in the fluid. Done everyone? Clear with this? Chalo. So basics are clear. So here also you can write this. So this where is it? This is the density volume of the complete solid. Vs is a volume of complete object. Okay, so whereas this is a volume of fluid displaced. Volume of fluid displaced, or volume of the solid immersed. You can also say that volume of the solid immersed. Done guys? Clear with this? Sure. So this is also done. So now we got one question. So let's try to solve this question on your own. So first read the question properly. So what's the question says? An ice cube of density 900 kg per meter cube is floating in water. So there is a ice cube which is floating. This is a, let's suppose this is a ice cube which is floating. So ice cube of density. So the density of the ice cube is given. So let's suppose I am considering the ice cube density is 900 kg per meter cube. So and the water density is given. The density of water is so 10 to the power 3 kg per meter cube. So this also we know. And then so the percentage of volume of ice cube outside the water is, outside the water how much percentage of the ice cube is floating. So the simple condition as it is floating. So first let's go for the law of flotation. As per the law of flotation, I can write like, so the rho f vf is equals to rho s vs. Rho f vf is equals to rho s vs. So now I don't know what is the volume of the solid. So let's consider the volume of the solid or ice. Volume of the solid or ice which is equals to 100 I am considering. See, let's consider 100. So now what is the density of the fluid? What is the density of the fluid that they gave? 10 to the power 3. So and then what is the volume of the fluid? So ice cube density is given. Okay, so volume of the fluid we don't know. So what is the density of the solid? We considered it as 100 into what is the volume of the solid? Density of the solid that they gave, sorry, 900 into what is the volume of the solid that we considered? 100. So fine. So from here, so let's write, so the Vf is equals to, so 900 into 100 by 10 to the power 3 means I am writing 1000 here. So 2 zeros cancel, 1 0 cancel. So the volume Vf, what is Vf here? So this Vf is a volume of the solid immersed, right? It's a volume of solid immersed in liquid. In liquid, or here you can directly take water. Okay, so when I consider the total volume as 100, so the immersed part is 90. So that means 90% is immersed and 10% is outside. Shall I consider like that? So now you understood, right, why I considered initially 100? Because if I consider the initial volume of the total solid as 100, so then I got, so the part which is immersed in the fluid or the water, 90. So out of 100, 90 is immersed inside. So 10% is outside. 10 is outside, which means 10% is outside. That's it. So how much it is outside? 10%. So outside the water they are asking 10%. Clear? So we have got one more question. So let's try to solve this question on your own. A body floats in water with 40% of its volume outside the water. When the same body floats in an oil, 60% of its volume remains outside the oil. So the relative density of the oil is, so the relative density of the oil. So there are two liquids here. So one is water, the other one is a oil. So hope you can solve this easily now. So they are asking what is the relative density. So a body floats in water 40% of its volume outside in water and 60% remains outside in oil. So just write these two equations, then equate them. Same previously we did write one question, same manner. So try this. See what is there, why you are thinking. See here. So here rho of water into, so volume of water is equals to, so the solid, what is the solid? So the rho s, let's write the general formula, rho s vs is equals to rho f vf. Yes, better this way. So then what is the density of the solid? What is the density of the solid? So let it be the density of the solid into what is the volume of the solid, percentage immersed in the water. Outside 40% means inside 60%. Here it's going to be total. Here also total, consider it as 100. Let me do this way. So the density of the water into what is this one, volume of the fluid which is immersed. So outside is 40% means inside it is going to be 60%. So what is the total density of the solid into 100 is equals to, so what's the density of the fluid? Water density is 10 to the power 3 into 60. So let it be equation number 1. So let's write for oil also. So the rho s vs is equals to rho o vo. Okay, so then what is the density of the solid? So let it be rho s into, so what is the volume of the solid that we considered? 100. So here the density of the oil, so what's the density of the oil? Let it be okay. So then the relative density of the oil only we require, right? So here let's write this is the density of water only. Let's keep it that way only, density of water. So then you'll get it easily. So then I'll write, so density of oil into what is the volume of the oil? 60% remain outside means here 40. So let it be equation number 2. So let's do one thing. I'll divide, so equation 2 by 1. 2 by 1 respective RHS. So rho naught by rho naught into 40 by rho w into 60 is equals to, so I'll write rho s into 100 by, so rho s into 100. Yes or no? So the density of the solid rho s into 100 into 100. So the volume of the solid I consider it as 100. So then I'll get here, so this cancel 1. So the rho is 1 is 60 by 40 by 60 if it goes outside. So 60 by 40. So 0 0 cancel, it is 1.25. So which is nothing but approximately 1.2. Yes or no? So 1.25 or 1.2 we can consider. 1.2 only, not 25 also. 1.2 only. Yes. So this is what we require, right? So rho of oil by rho of water is nothing but the relative density of the oil. Density of oil with respect to the water is nothing but the relative density of the oil, right? So which is 1.2. Option 3 is a correct one. Clear guys? Understood this concept? So just you have to take care of the calculations, that's it. Done? Chalo. So did the calculations correct? Sorry, wait a minute, calculation I did wrong I guess. 6 by 4, right? 60 by 40 means 6 by 4. So 2 2s are 2 3s are. So 3 by 2, 1.5 guys. Options are closed. That's what I am checking. So the options are closed. So which is 1.5, not 1.2. 1.5. So chalo. So can you guys take this question as a homework? So let's take this as homework 1. So this question and this one homework 2. And so what else we have? So we have one more question, homework 3. So 3 questions and one more question, 4, homework 4. So try these 4 questions on your own. So if you are not getting, I'll limiting condition for floating, we'll discuss it in the next session, and we'll also start the fluid dynamics in tomorrow's session. So but before that, you should try these questions on your own. Okay guys, hope you guys understood today's lecture. We'll meet in the next lecture with the fluid dynamics concept. So till then, keep studying. All the very best. Bye.